Hello and welcome to Dubai Trains, and today we're going to make that signaling system that I explained in a recent video. And in that video I explained how I came to this design, so I don't want to go over that. I do think we need a little short recap of how it's going to work, and then I'm going to talk to you about the components and the parts and how I installed everything. I try to explain to my best ability how it all works. So let's just get started. So the system in a nutshell is basically two sets of two variables. So the first variable is there an operator in the near north section of my layout? And if the answer is no, then all the signals going into near north are basically just plain straight out orange. If the answer is yes, then it can either be green or red, depending on some factors. So we need to switch that. So let's start with the basic setup and proof of concept. Here we are on the bench work. We have a signal, we have a timer. Yes, I'm using a timer-based system. But you can also hook sensors up to the timer. So you have a timer and sensors. I hooked it up to some power. That's right here. We'll go for that. And then here we have a switch. So if I turn the system on, you'll see it is on 0 seconds and the aspect is red. And if I press the button, it starts to count down from 17 seconds and the aspect turns green. So how does this all work? Let me try to explain it in super easy, simple, basic terms. Power always needs to make a circle. So here we have power input. We have two wires, one is plus and one is minus. Power always has to go from the plus to the minus. So this whole block, everything connected to it is plus. It's all the same. So first step, we need to power the port itself. So we have one plus going from this block in red to the timer, and because it has to do a loop, it goes in black to the minus to this block. Everything on this block is minus, and then it goes through the power cord back. So that's the timer, that's the spoken for. Now we have a trigger right here. This is the trigger, and the trigger is that third input right there, and it needs to be powered. So we're basically getting another power wire from the plus that goes to the trigger, and then the trigger goes here to give a signal to the timer that it needs to start counting down. Now there's another ground wire right here. We're not doing much with that, so that's just going to go to the negative. Now we need to power the LEDs. So how do we do that? This signal has two aspects, yet it has three wires. So it has what's called a common wire. That's this one, and that goes to the signal. And then we have two wires coming back, one for the green light and one for the red light. In this case, the wire is orange. And that's how the power loop goes. So we go from the plus through the common to the signal, and then we have two wires back, one for each LED, through the common to the minus. Now, how do you decide what? Well, a relay is basically a switch. That switch is either one on or the other on, and if this one is on, then this one's off, and if that one is on, this one is off. And you have a normal stand, it's resting position, you could say, and in that stance there is something called a normally open and a normally closed. So normally, I think gravity-fed relays normally closed is down. So that means that this pole right here is NC, normally closed, and then the top one is NO, because in a normal position, resting position, it's open. There's no current going through that. So that's how the switch goes, something like that. Anyway, long story short, and now it's in resting position and it's red. So the normally closed is connected to red. That's this guy. And the normally open in resting position is green, and it's not green. And if we press the button, the relay is powered. Then it goes from this position to that position. And then the normally open now all of a sudden is closed, and the normally closed all of a sudden is open, and the other LED is burning. Very simple. So now let's crank up the complexity, because this is a two-aspect system. Let me just turn this off and wipe that away. And here is the diagram, because we also have two sets of three aspect signals on the layout. So if you remember, there's going to be a signal right here, 3.2 and 5.2, and there's another set of three aspect signals here, 2.1 and 2.2. So we're going to need 4 timers. That's what you see here. Okay, this is the timer board, and we have 1, 2, 3, 4. There's a dotted line in between here because there's two different locations. There's one location here and one location there, and there's going to be 3 wires traveling from the two relatively distant locations, so to make it all work. So if you think this all looks very complicated, don't worry, it's not. Everything is drawn in here, most of it we already just discussed. So here we have the timer board, and well, it's pink, but that's all the red plus wires, and in the blue it should be black, but I don't have a black marker. So in blue we have all the minus wires, and as you just saw, we have the NC normally closed, we have the red LED, and in the normally open we have the green LED, and then the common wire went all the way back to the power supply as well. And this is where it's going to get a little bit different. It's because we have the third orange aspect, and we need to switch this entire orange aspect. So how are we going to do that? Let me try to explain it really simple. So here we have a signal bridge, and it has two sets of each three aspects. So we have a whole heap of wires coming out of here, but we're just going to focus on these three wires, and this is the easiest way for me to explain how this is going to happen. So the red is the common. Yeah, you need to get your head around these colors a little bit. So here we go. The red is common, and then we have the green and the red aspect. So in the previous example with the this signal right here, we switched between the red and the green with the timer. So this was all connected, and the switching was done with the timer right here, and the common was always connected. But now we have this extra dimension where we also have an orange. So how are we going to switch between this? I already said it's going to be with a switch, and the switch is going to determine if the common goes to the orange and this loop is complete, but because the common is not connected here, this is not going to work. So we have orange, or we switch the common back to the timer, and then with the timer module we can choose between green and red. So one switch, common goes, completes the loop with orange, and flip the switch, common goes to the timer, and then we can choose with push button and the timer system if it's green or red. So having said that, going back to the diagram, here is our switch right here. So it's now in the position where it closes the common with the timer. So you can choose between the red and green LED. And this switch is connected to all the other timers as well. You see this blue line goes all the way down. Because remember, all these systems either have an individual mode where you select each timer if it's green or red, or the switch right here goes bloop to the orange, and then the common is off of the timer, so none of the timers work, but it's on the orange, and you complete the circle with the orange, and all the orange aspects are running or showing. So enough for the theory. Enough for the theory. So while we get a little bit organized, do you think I'm a good teacher? Do you think I should be teaching more? I don't know. I don't know if I would even understand myself. Anyway, so here we have all the different parts and components. Let's just talk a little bit about that. We already talked about the timer. I have several of them, and we do need to talk about that a little bit more because I don't want you to buy the wrong one because I already bought the wrong one for you. Here we have them. So let me tell you how I made the mistake, so then you might be, you might understand why certain ones are not good. So here is another relay timer, and it's great. It has a NC on it, that's what we need, and an O on it, and only close, only open. And this works. Actually, we made it with this, we tested with this, and it works. But the downside is you have these two little meters, and you're going to use one of them. And this little meter, you can turn it about, I think, like 320 degrees or something. But with that 320 degrees turn, you select between 3 seconds, which is the minimum value, and 120 minutes. So I don't know how many, that's like half a minute per radial degree turn or something. I don't know. But you can't basically adjust this accurately enough to adjust the timer to anything that you need. It's either going to be like 3 seconds, which is the minimal, or it's going to be like a minute and a half, and that just doesn't work. So I realized that after I bought them and they were on the way over here. So anyway, that's one you shouldn't buy. And then I bought this guy, so I thought, this is a timer, and you can go up to the millisecond, I think. This is what I need. But there's one big difference. This has a relay on it. And a relay, as I explained, is basically a switch that can be open or closed in one of two directions, and you always have two different outputs. If it's like this, one is on, one is off. If it's like that, one is on, one is off. You have two. This guy doesn't have a relay. As you see, this big block is the relay, and this one doesn't have one. So that basically means there's no on or off. There's just only one output, and that one output is on, or that one output is off. And we need two outputs, an NO and an NC, of which one is always on and one is always off, or the other way around. So this guy doesn't work. But then I did find the timer that I settled on now. That is more or less the same, but instead of these two units right there, has the relay unit. And you see it also has an extra port. I think if you like that, you can compare it a little bit better, because these four are the same as those four, but here we only have two, a ground and an out, and here we have a common and a normally open and normally closed. So don't buy the wrong one, you have been warned. I'll put a link in the description down below with the right parts if I can find them for you. Now you want to get organized. You already saw my demo unit. I like to use these lever wire nut connectors. The official word. I think Wago is the official brand name. This is just some knockoff thing, but it works amazing. You just pop the wire in there. It can be everything from a thick wire to a thin wire like this. I can just show you. So take one that's stripped like this, a tiny little wire. You just jam it in there. Close the lever wire nut thingy-majingy, and it's stuck. It's really stuck, and it makes a solid connection. And you can also take, just as contrast, a big old gauge like that. So that was that. Get an assortment box. You're really going to want to have that. And now basically what I'm doing is I already pre-assembled everything. So you already saw my signal bridges. I already put wires on here, and all these wires with these little connectors that I got and that I put on there is another assortment pack, color-coded, pre-plugged. Anyway, that's nice because it helps with the color coding. And now, basically, if you look at the diagram, we have 1-2 unit. These two are over here. They're also physically on the layout in the same area. Then we have that long cable, and then we have 1-2 unit. These are physically in a different part of the layout, but together as well. I'm just slowly making that. I have the parts here. This will be one part of the layout where we have 1-2 unit. And I'm making a second one over here. I got my push buttons. It came with a cord, but of course the cord wasn't long enough, so I just extended that a little bit. I pre-made all these. So what you do is just at some point when you're ready for it, you just take the wire, put it in the lever wire nut connector, close the lid, boom, done. No soldering, that's that. I bought, measured, and pre-stripped and pre-tinned my cable. I got a special cable with 4 cores. Yeah, I pre-tinned that, so this is all ready to go as well once I'm ready for that. And that's it. I'm just going to assemble it, and then I'm probably going to do a dry test here on the workbench first, and then once all that works and all everything is connected, only then am I going to install it on the layout. Here we are, everything has been installed, and if I just flip on the power switch, you'll see all the timers are starting up, and it looks like a mess. And if you just stick to the color coding, it actually isn't a mess. Actually, even for me, the non-electrician, it's quite easy to follow. Now I do want to add, you can add a light sensor to this unit. It basically just becomes another trigger. And that means if that is triggered because the train passes through it, then the timer will just reset. Those programming modes are available in this timer. So it just basically means if it's triggered twice, so let's say 1, it goes green aspect, and then the train would trigger the light sensor, then the timer would just reset back to 0. That functionality is in here. Now, this is all done. Oh, still need to talk about this guy. This guy has some faulty wiring on the inside. It's from the company We Honest, and they are honest. It's cheap as chips. You get what you pay for. So this one, I think one unit is faulty. To keep the show on the road, keep the show moving, I ordered another one. And just to make sure it's not in this series of signals. I also ordered 2 separate signal masts that I can place on either side of the track. So now this is all working on the benchwork. It's time to get it installed on the layout. I already drilled some holes right there. Let's get cracking. So that is the signaling system installed. It was actually relatively easy. I tucked it all, if we just have a peek, I tucked it all, this mess underneath with these Velcro cable tie thingy-majingies. So let's have a look, and let's have a look at the signage as well, and once more go over it, how it works. And let's start with the yard. The yard is the most basic of 2 aspect signals, and it's either going to be red or green to protect the yard from incoming traffic. And it's really simple. You can press the button for signal number 3.2, northbound, proceed. The arrow is in direction of travel, just to make it easy for everyone. Press the button, let me show you, and it goes green. And again, it's timer based, so this only this signal is 24 seconds. All the other signals are 17 seconds. I added a few seconds to that because sometimes we actually have a lot of traffic coming from the near-north switching area, and they already asked for permission a little bit earlier. So I set the timer a little bit longer so they have time to actually get to the signal and then go through signal while it's green. So that's one side of the yard, and then we have this other side of the yard. Here we have the president of the layout. Please welcome him. Visiting the new signaling system as well. Unfortunately for him, we don't have any fancy coaches. We just have these converted trooper sleeper 50-foot boxcar things going on. So here we have another signal, and the signal is actually pointed in that direction. But to make it a little bit easier to see for everyone, I put this mirror here. It's one of those mirrors you can put on your side wing mirrors on your car for your blind spot. Press the button. There we go to green. Button is more same arrow, that direction travel. Signal number 4.2, southbound, proceed. So that is the yard. We protected that now. So let's just quickly go here. That's the yard, that's what we're just talking about. So there's a signal there, 2 aspect signal, that direction, signal there, 2 aspect signal, that direction. And then for near north, as you remember, first question, is there an operator available? Is there anyone in near north? And if the answer is no, then we have restricted speed. So that's what you see here. There's a flip switch right here. No, we have restricted speed. And restricted speed on my layout is 10 miles an hour. And then all these signals are on yellow or orange aspect. I think you can see it just right there. And those 2 signals here are also on yellow for restricted speed because there's no operator in near north. And because they're yellow, I have more buttons here. You can press whatever you want, and the relay will actually switch, but the signal remains on yellow. The signal does not change aspect. So that's one scenario. Is there anyone switching in near north? No, then you have restricted speed to travel through near north. However, if you remember from my last video, orange, if you will be switching near north, then you are the operator until you exit near north. So that means if you're here in the yard, and you're going through this signal, you're going to be operating in near north, you're going to be the operator for near north. You're going to flip that switch to operator, and lo and behold, everything goes to red. All the inbound signals to near north. So that one's red, and these 2 are red as well. Maybe it's a bit difficult to see, but I assure you they are red. And now you need to ask permission to get into near north. And if you get permission, let's say from this track, press the button, and presto, that aspect turns to green and permission to proceed. And it's the same here. If you can see it, goes to green and permission to proceed. Now the permission to proceed will come with an instruction as well. It could be simple as please proceed track 2, 3, hold at Chicago Avenue because there's oncoming traffic. That's just using track 2 all the way through, something like that. Or proceed and caution after Erie Street because there's another crew working there or something along those lines. And then once the last crew has left near north, the operator is going to flip the switch to restricted speed, and then the orange aspect will show. And again, it's restricted speed through near north, or the first person crew into near north going to switch that area is going to be the operator. And that's basically how it works. It's quite straightforward.
One thing I want to do later on is actually add a keyed switch. So you need a physical key to switch from restricted to operator. I didn't find a keyed switch yet that has on, only on-off, and that's not what we need. We need on. Anyways, that is the system. And what rests now is to update the scheme, the schematic I have on this piece of A4 paper to the one you're seeing now, which is nice and colorful and which is accurate. And I'll post this on my Patreon on the second tier in case you want to download it in a good quality. And please feel free to ask me any questions there if you may have it. It comes with the Patreon membership. And lastly, but not least, down in the description below, I'll add a link to the various components that I used to make the system, so you can have a try at it yourself. Now stay tuned for operating videos where I'm going to use the system and explain it step by step again and again. And that's it for today, guys. Thank you all for watching. Bye-bye. Mileage may vary.